to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
I don't know about you, but I've been eating a lot of comfort food and watching a lot of comfort TV recently. Now, I like shows that make me feel happy, so I've been watching a lot of Parks and Rec. Parks and Rec is my all-time favorite TV show. If you haven't had a chance to watch it, I highly recommend it. Now, one of the things that makes the show so great is the characters. One of my favorite characters is Leslie Knope. Leslie loves Friends, waffles, and work. Leslie prides herself on being organized and prepared for anything. One of the ways she makes sure she's prepared and organized is by creating binders. When she needed an emergency preparedness plan, she made a binder. When she was deciding if she should take a job, she made a binder. And when her friend decided she wanted to have a baby, Leslie created color-coded binders to show her support. Leslie's binders are amazing. They're full of details and plans so that anyone who picks one up doesn't have to go through the effort of working through the details themselves. They can simply pick up a binder and quickly become successful. Now, you might be wondering, why is Lauren talking about Leslie Knope and her amazing color-coded binders? Don't worry, I've got a point. Last spring, I built an app so my team could easily visualize how many people we are reaching on Twitter. I built the app using MongoDB Realm serverless functions. As I was building the app, I realized that having a CI/CD pipeline would make building and deploying the app easier. I knew it was possible, but I struggled to find the resources to help me figure it out. I also realized I needed to have a set of automated tests so I could speed up my development and feel confident in my automated deployments. I quickly discovered it was going to be much more difficult to create a CI/CD pipeline than I initially thought. I didn't even know how to write unit tests for my app. I really needed a Leslie Knope style binder on how to create automated tests and a CI/CD pipeline for my app. Unfortunately, no binder existed. So I spent quite a bit of time figuring this all out myself. Now, I want to be your Leslie Knope. I've created a binder so that you don't have to work through the pain of figuring out automated tests and the build and deployment process yourself. Instead of creating a physical binder, I've created a digital binder in the form of a GitHub repo for you. The repo contains working automated tests and CI/CD infrastructure code that you can shamelessly borrow. The repo also contains a detailed README with explanations of how everything works together. So today I'm going to walk you through that digital binder. I'll give you the GitHub repo at the end of this presentation. So when this presentation ends, you'll know how you can use my digital binder to jumpstart the creation of your CI/CD infrastructure for serverless apps that are built on MongoDB Realm. Now, throughout this presentation, I'll share what I learned along the way as I built this binder. And by the end of the presentation, hopefully you'll feel like this. So before we dive in, let me introduce myself. My name is Lauren Schaefer. I began my career at IBM, where I spent 8 years as a software engineer. I held a variety of roles there, including test automation specialist and full stack developer. I spent a couple of years working on a product called IBM DevOps Services, which provided tooling to help developers and operations people be successful as they implemented DevOps best practices. I currently work as a developer advocate at MongoDB, where my job is to help developers be successful as they use the MongoDB platform. You can find me on both Twitter and TikTok with the handle Lauren_Schaefer. Now, I'm relatively new to TikTok. I'm one of those annoying millennials who decided quarantine was a great time to join TikTok. I am having a lot of fun with it, so look for me there. For those of you who like to follow along with the slides on your own machine, you can find a copy of the slides on my Twitter page. They are currently pinned to the top of my profile. All right, let's get back to the presentation. I have carefully crafted the equation on the slide for you. DevOps plus serverless equals starstruck emoji. Okay, so how are we going to make sure you leave feeling like a starstruck emoji? Here's the plan. Now, I've already been using terms like serverless and CI/CD and MongoDB realm, and maybe we've got different definitions. Maybe you don't know what I'm talking about. So I'm going to begin by getting us all on the same page around terminology and concepts. Then I'm going to give you a demo of the serverless app I've been working on. Now, demos are always a little scary for presenters, so hopefully it'll go well. We'll see. Then I'll give you an overview of how the app and the DevOps infrastructure are implemented. Next, I'll give you another demo, another one, where I'll make an update to the application code so you can see the process of how code moves from my laptop through the various stages all the way to production. You'll get to see a little bit of the test automation and take a look at the builds in Travis CI. And finally, I'm going to wrap things up by sharing with you what I learned and how you can get a copy of the code and resources I'm presenting today. All right, so let's jump right in by getting everyone on the same page around terminology and concepts. So I'm going to walk you through 5 terms. First up, let's start with that first part of the equation, DevOps. Now, DevOps is a portmanteau that combines the words development and operations. DevOps aims to combine and merge development and operation teams together to rapidly build and deploy high-quality software. DevOps has a variety of best practices associated with it. Some of those best practices are related to culture and teams, while others are focused on build and deployment infrastructure. Today, we're going to be focused on the infrastructure part and specifically on how to implement CI/CD. Okay, so what is CI/CD? Well, CI/CD stands for continuous integration and either continuous delivery or continuous deployment. Today, I'm going to be using CI/CD to refer to continuous integration and continuous deployment. Continuous integration refers to the practice of continuously integrating developer code to avoid conflicts. Continuous deployment refers to the practice of frequently deploying software. Now, in order to benefit from CI/CD, you need to have a lot of automated tests that your team trusts. If the tests pass, your code will automatically be deployed. When your team utilizes CI/CD, you're able to get value to your end users faster. Many tools exist to help you implement CI/CD. Today, I'm going to be using Travis CI as it's a popular CI/CD tool that is free for open source projects. And I like free things. But you can use whatever tool you'd like. Jenkins and Circle CI are other popular choices that you could use as well. All right, now let's talk about that second part of our equation, serverless. Serverless does not mean no servers. It just means that the developer doesn't have to think about them. So the developer will write a function, and the cloud provider handles executing the function on its own servers. In the serverless world, developers don't have to worry about servers or containers or infrastructure. Instead, they get to focus on the application code. In a serverless architecture, you typically write serverless functions. These functions can be triggered by various events, which could be things like a timed schedule, an authentication event, a database event, a call from the client code, or even a manual call. If you're used to working in a traditional monolithic application in the platform as a service world or in the containers world, this is a big architectural change. You no longer have long-running server-side applications. All right, MongoDB Realm. Let's talk about it. MongoDB Realm is a serverless platform that makes it easy to build modern cross-platform apps with MongoDB. Today we'll be focusing on serverless apps that are built using MongoDB Realm. Now, MongoDB Realm is comprised of 4 separate services. I'm going to hit them quickly. First up, we've got SDKs. Realm has client SDKs for JavaScript, React Native, Android, and iOS that enable cross-platform client support. The second Realm service is functions. Functions allow you to write server-side hosted JavaScript functions. These are standard ES6 functions that can be called from service actions, REST API requests, or our SDKs. Functions execute in a serverless way, so you aren't having to worry about hosting backend code on one of your own servers or some platform as a service. The next service is triggers. There are 3 types of triggers: database, authentication, and scheduled. And finally, we've got Realm Sync. This service syncs data between your mobile devices and your backend in real time. So today we're going to really focus on that second service, serverless functions. Many other cloud providers offer serverless functions, and you can apply the concepts I'm sharing today to those platforms as well. All right, one final term that you'll hear me talking about throughout this presentation, MongoDB Atlas. Atlas is MongoDB's database as a service. It's fully managed by MongoDB, so you don't have to worry about any of the management headaches. So instead of trying to host my database locally on my machine, I'm going to do everything today in Atlas. Atlas has a generous free tier, which is great for development. You can do everything you'll see me do today on the free tier. All right, now we're on the same page with terminology. Let's talk about why I'm giving this presentation. Why is implementing CI/CD for serverless apps so hard? When I was implementing CI/CD for my app, I ran into 3 big obstacles. First, figuring out how to write tests for serverless apps can be really tricky. In fact, I had to do a lot of digging and eventually found a bit of a hack that let me write unit tests for my serverless functions. Second, researching testing frameworks can be time consuming. I'm sure many of you have opinions on your favorite testing framework. And third, writing CI/CD infrastructure code can be tedious and a bit of a time suck. The thing is, doing all of those things I just listed is work that doesn't provide value to your business. If you're a developer, I'm guessing you'd rather be writing code for your app instead of building the underlying CI/CD infrastructure. If you're a decision maker, you probably feel the same way. You'd rather have your team just breeze through the infrastructure part and get right to building your app. All right, so now that we're all on the same page, I want to demo for you the app that I've been building. Understanding what the app is and how it works will hopefully help you understand why I have architected my tests in the way that I have and help you understand how my CI/CD infrastructure code works. So let me show you my social stats app. The app solves a problem we as a team were having. We wanted to be able to easily gather stats for how many people we as a DevRel team are reaching on Twitter. So I'm going to jump over to my browser. All right, so here I am inside of Twitter. I'm inside of their analytics section on the tweet activity page. So here you can see some stats about my tweets. But if you want to get really detailed information, you want to download it. So I'm going to choose to download my stats for the month of October and choose to download them by tweet. It'll take just a moment for that to download. You can hear the garbage truck going by as we wait for it to download. It's a treat, isn't it? Nothing like a demo to slow down your internet speed, right? All right, there we go. So let me open up that spreadsheet. Drop it over here. All right, let me punch this up, make it a little bit bigger. Is it getting bigger? No, it doesn't look like it. Okay, so here we get a whole bunch of stats. So we can see things like the tweet ID, a link to the tweet, and then what I actually wrote in the tweet. If I keep scrolling over, we get the data I really care about, impressions and engagements. So impressions are how many people saw your tweet. Engagements are how many times someone interacted with your tweet. For example, an engagement could be a retweet or a like. Now these spreadsheets are handy, but we as a team need an easy way to roll these stats up and combine them together. We want to make sure we aren't double counting stats from a previous spreadsheet. So I decided to create an app. Now let's take a look at it. This is the ugliest app I've ever created, so please refrain from hating on it. I know it's ugly. Let's move on. Okay. So what I can do is upload a copy of the spreadsheet I just downloaded. And what it's going to do is process all of the tweets in that spreadsheet. The app is going to save the tweet statistics in a MongoDB database. The benefit to keeping things in a database instead of a spreadsheet is that I can programmatically take care of duplicate tweets to ensure I'm never double counting statistics. So once the file is uploaded, I can click on this super ugly link up top and open up a dashboard. So here I have a dashboard with 4 charts on it. Here we can see engagements by month, impressions by month, total engagements, and total impressions. So here we can see the engagements by month chart is broken up by team members. So we can see there's a lot of green on this chart. Otto is having a great fall on Twitter. Way to go, Otto. Now, if I want to narrow the results to see just how I'm doing, I can do that. So I can update the filter to just show me. So it'll take just a moment for that to update. There we go. So I can look at my stats, pull numbers just for me, which is great. Or if I wanted to pull numbers for just a particular month, like let's say I wanted to grab my stats for September, I could say grab previous month, and my stats will update. And this is helpful. I can dump these in my performance review to show how many people I'm reaching. So the nice thing is anyone on our team can come into this to view these charts and filter them as they see fit, which is pretty handy. All right, so that's it. That's my super ugly but super functional app. All right, so now that you have an idea how the app works, I want to show you the app architecture as well as the CI/CD infrastructure. So let's begin with the app architecture. When a user accesses the index.html page, they are accessing the index.html page that is hosted by Realm. When a user uploads their CSV file with all of their Twitter stats, index.html encodes the CSV files and calls the process CSV serverless function. That function is in charge of decoding the CSV file and passing the results to the store CSV in DB, standing for database, so store CSV in DB serverless function. That function calls the remove breaking characters function, which is just a helper function that simply removes any bad characters from the tweets. That function passes the results back to store CSV in DB. Store CSV in DB then converts the clean tweet statistics to JSON documents and stores them in MongoDB Atlas. Remember, Atlas is what's hosting my database. All right, then the results are passed back up the chain and ultimately displayed on the web page. Now, if that was a little confusing, don't worry. Basically, we've got an index.html file hosted on Realm. It calls a series of Realm serverless functions, stores information in a database. All right. When we view the dashboard with all of the charts showing a summary of our tweet statistics, we are actually accessing a MongoDB charts dashboard. If you aren't familiar with charts, I recommend you check it out. It's a very easy way to visualize your MongoDB data. So what's happening is that our dashboard is pulling data from MongoDB Atlas and displaying it. All right, so let's slide that architecture diagram to the left of the slide and talk about automated tests. I'm going to talk about tests in the form of the test pyramid, which you may have seen before. So at the bottom of the pyramid are the unit tests. The unit tests test each serverless function individually. I chose to use Jest for my JavaScript testing framework as it's a popular choice, but you could choose to use whatever testing framework you like. I find Jest to be fairly intuitive. Now, since these are true unit tests that don't test the integrations between a function and other code in the system it interacts with, I had to create a lot of mocks. I found the initial creation of mocks to be fairly challenging, but once I figured them out, I was able to reuse them pretty easily between test classes. Honestly, mocks make my brain hurt a little bit, but they were completely necessary for me to be able to write true unit tests. And this is fairly common with serverless apps. Serverless functions frequently interact with other functions and services and databases, and that's all by design. So you'll need to create mocks if you want a unit test that can be run without actually hitting those other functions, services, and databases. Now, if you aren't sure how to create mocks in your test code, you can check out my GitHub repo or do some Googling. All right, let's move up our test pyramid and talk about integration tests. Our integration tests test the integrations between our functions and the database. My tests actually look quite similar to what I wrote in my unit tests, except instead of using mocks, I just used the real integrations. Now, just as I did with my unit test, I used Jest as my testing framework. One important thing to note is that in order to test these integrations, my code must be hosted in a Realm app in the cloud. I don't have a way to run the integration tests against local code. Another important thing to note here is that these tests interact with my database. I've architected my tests to clear the database before every test, so I do not want to run these tests against my production app. Now, up at the top of my pyramid are the UI tests, sometimes referred to as end-to-end tests. I won't get into the differences here. I'm sure many of you have opinions on that. These tests interact with elements on my index.html webpage. The tests upload a CSV file with tweet statistics and then navigate to the dashboard to ensure everything was processed correctly. I've chosen to implement my UI tests using Selenium and Jest. Similar to the integration tests, these tests rely on code hosted in a Realm app, so I cannot run these tests against local code. Also, they interact with my database, so I do not want to run these against my production app. Now let's take a moment and talk about the test pyramid for serverless apps, as this is one of the things that I learned while working on my app. In the traditional test pyramid, the recommendation is to have a lot of unit tests, some integration tests, and then a few UI tests. The higher you move up the pyramid, the fewer tests of each type you have. This is how the pyramid gets its shape. In serverless apps, the pyramid may be shaped a little differently. Now in my case, I had about the same number of unit tests and integration tests. I've got far fewer UI tests, as those are a lot more brittle. So my test pyramid looks more like a house. Now some people have shared that they have more integration tests than unit tests. So their pyramid might look more like a funky geometric shape, and that's cool too. Integrations are super important for serverless apps, so you want to make sure you've created enough automated integration tests to adequately cover your integrations. All right, so now I've shown you how I've architected my app and my test infrastructure. Let's talk about how I move code from my local machine through the various stages and into production. I want to walk you through the stages of my CI/CD pipeline. I'm going to begin by giving you just a high-level overview with diagrams so you understand what's happening conceptually. After I explain this, I'm going to demo it for you so you can see it in action. So let's talk about the 4 stages of my CI/CD pipeline. First up, I've got my local machine. Now this is where I do my development. I can write serverless functions and unit test them here. I can also create web pages and view them locally. When I'm ready to see how it all works together, I'm going to put the code in my development stage. I'll talk about how the code gets there in just a moment. The development stage is just for me and my code. Every developer is going to have their own development stage. When I feel good about my code, I can push it to staging. Staging is a place for all of my teammates to merge our code together and see what it's going to look like in production. If we want to do manual testing, this is where we do it. If all of the automated tests pass, the code will automatically be pushed to production. Now in my case, I've got 4 stages. Depending on your team's requirements, you may have more or fewer stages than this. You might have different names for your stages. For example, some people might have a QA stage or a test stage. That's all good. But here you can get the idea of what multiple stages look like, and you can tailor the stages for what works for your team's workflow. Now that we have an idea of what the stages are, let's take a few minutes to dive into the details. Because we don't want to have awkward, clunky movements between the stages. We want a nice, smooth pipeline. So let's begin by talking about how we can work locally on our machines. So first, I'll have a local copy of my development branch from my GitHub repo. The repo stores everything in my app, including my hosted HTML files and my serverless functions. When I'm working locally, I can run unit tests that test my serverless functions. Since I don't have a way to run a Realm app locally on my machine, that's all I can test. I'll need to push my code to Realm in order to run manual tests, integration tests, and UI tests. So how do I get my local code on Realm? I'm going to push changes to the development branch of my Git repo. My development branch is specific to me. My teammates have their own development branches. One of the nice things about Realm is that it has a GitHub auto deploy feature so that whenever you push changes to an associated GitHub repo, the code in that repo is automatically deployed to your Realm app. So when I push my changes to my development branch, the changes will automatically be deployed to my Realm app. That Realm app will be associated with an Atlas project. The Atlas project is where my database lives. Now in my case, I chose to have separate Atlas projects for each stage so that I could take advantage of the free clusters in Atlas. If you're paying for clusters, you can easily use a single Atlas project for all of your stages. Finally, the Git push is going to trigger a Travis CI build. The build is responsible for running all of my automated tests. The build is going to run those tests against the Dev Realm app that was just deployed. If you have experience with CI/CD infrastructure, this might feel a little odd to you. Travis CI is responsible for running the tests, but not for doing the deploy. So even if the tests fail, the deploy has already occurred. Now this is okay since this is not production, it's just my dev environment. Before we move on, let's summarize what's happening here. When I'm done working locally, I'm going to push my changes to the development repo. That push puts the code in my repo, triggers the deploy to my Realm app, and triggers a dev build on Travis CI that runs my automated tests. All right, so now we're in the development stage. My code is in my development branch. My code is deployed in my Dev Realm app, which is connected to my Dev Atlas project. At this point, I can choose to run manual tests against this deployment. I can also use my local machine to run automated tests against this deployment. When I feel like my code is well tested and I'm ready for a teammate to review it, I'm going to create a pull request. If you're not familiar with pull requests, I'll show you one when I get to the demo in just a few minutes. Basically, pull requests are a way for me to request that my code be reviewed and considered for merging into the team's code. If my pull request is approved, it will be merged into the staging branch. When my code is merged into the staging branch, it will be automatically deployed to my staging Realm app that is associated with my staging Atlas project. The merging of my pull request is also going to trigger a Travis CI build. That build is going to run all of my automated tests. If the build passes, meaning that all of my automated tests pass, the build is actually going to automatically push the code changes to my master branch. I'll come back to this in a moment when we talk about the push to prod, so just remember that this staging build is doing something special if everything goes well. So to summarize what's happening here, when my pull request is approved and my code is merged, my code will be in the staging branch, my code will be automatically deployed to the staging Realm app, and the staging build will be automatically kicked off. All right, now we're in staging. My code is in the staging branch. My code is deployed in the Staging Realm app, which is connected to the Staging Atlas project. At this point, I can choose to run manual tests against this deployment. This stage is a simulation of production, so it's your place to do all of your QA testing. If I want to run the automated tests, I can use my local machine to run the tests against this deployment. So now let's talk about how we move to production. Since we're following the continuous deployment model, we have a ton of automated tests. Our team has agreed that we feel confident that if all the tests pass, we are ready to deploy. Now, recall back to the staging build I talked about a moment ago. I told you that if the build passes, meaning that all of the tests pass, the build is going to automatically push the code changes to production. So instead of having a manual git push or a pull request trigger our move to production, we're actually going to have the staging build do the git push for us. So now our code is in our master branch. We still have the GitHub auto deployment feature configured, so that push to the master branch is going to trigger a deployment to our prod realm app. That prod realm app is associated with a prod atlas project where our prod data is stored. Finally, that push to the prod repo is going to trigger our prod build. The prod build only runs the unit tests. Recall that our integration and UI tests interact with our database, and we don't want to mess up our prod database, so we are only running our unit tests. Now, in my case, the pipeline stops here. You may have monitoring or other tools or tests you want to run here. It all depends on what your team's requirements are. All right, so one last time, let's summarize how we're moving from one stage to the next. So if our staging build passes, it's going to push the code changes to our master branch. That push is going to trigger a deployment to our Realm app, as well as trigger the Travis CI build. All right, now we're in our final stage. We've made it to production. Our code is in the master branch. Our app is deployed in the prod Realm app, and our prod data is in the associated prod atlas project. If we want to run tests, we can use our local machines to execute unit tests against the code in the master branch. All right, so now that you have a conceptual view of how code is moving through the CI/CD pipeline, let me actually show you what it looks like in action. I'm going to make a change to the app and show you how the code flows through each of the stages. So let's take a look at the app again. All right, here we have a nice little message that says, success, 7 new tweets was or were saved. Let's update that to be a little more snazzy. So let me open index.html in my code editor. So instead of saying success, let's say fabulous. Yeah, jazz it up a bit. All right, so I'm working locally. I can run the unit tests to make sure everything is still passing. Now, the unit tests don't actually, yep, they are still passing. We had a intentional throwing of an error there. That's what that red was. So my tests are still passing. We're in good shape. The unit tests don't touch my HTML files, so it would be pretty surprising if something actually failed here. All right, so now we feel pretty good about our changes. I'm going to commit them. So let me open up my Git helper here. Let's take a look at our change. We can see we're just updating one thing, so I will stage it. And I'll add a helpful commit message, try to be a good developer, and I'll say update success message. And let's commit that. And I'm going to push that change to my repo. All right, so let me hop on over to Realm and take a look. So I'm going to refresh this deploy page. And we can see we do have a deployment pending right now, which is great. Let me refresh it again. And okay, we can see that deployment was successful. So when I pushed to my repo, the deploy was automatically kicked off for me. That push also kicked off a build on Travis CI. So let's take a look at that. Here we can see we've got a build running on my dev Lauren branch. All right, so while we're waiting for that build to run, I want to show you the hack I used to write unit tests for my serverless functions. So let me open up a serverless function. Here we go. All right, so this is my remove breaking characters functions. It's a really short function. It's a helper function. It uses a regular expression to remove certain characters from text. By default, Realm serverless functions are formatted like this. They are required to be of the format exports equals function, blah, blah, blah. The problem is that there's no way to call this function from another JavaScript file. So what I did is add these 3 lines down here at the bottom. Let's break down what's happening here. If the type of the module is an object, the function is being executed outside of a Realm environment. So we need to assign our function to module.exports. If the type of the module is not an object, we can then safely assume the function is being executed in a Realm environment, so we don't actually need to do anything special. So let's take a look at a test case that's testing this. Here you can see up at the top that I'm able to import that remove breaking characters function just as you would import any other JavaScript file. So just remember, if you get stuck trying to figure out how to unit test these functions, there is a hack in my GitHub repo that you can borrow. All right, let's jump back and check on the build. It looks like it should be wrapping up any second now. So let me scroll down to the bottom. And it looks like the build failed. Great, that is exactly what you want to see in a demo. Okay, let's take a look at what's happening. I'm scrolling like a crazy person. Okay, we had 2 tests fail. Let's take a look. It looks like the failing tests are happening, in my UI test. So let's take a look at what's happening there. Let's jump back over to my code editor. And let's open up here's our test file. Nope, that's not our test file. Here's our test file. Let's take a look. Oh, you know what? It looks like we actually hard-coded in that success message. So let's fix that. So let's change it and say fabulous. And let's check for any other instances where we wrote success. We'll just drop that in there. Okay, so let me save that change. And I'm going to commit this change and we'll say update test for new success message. I'm going to commit that change and push it. Okay. So now that my code is deployed in my dev environment, I could choose to run my tests locally, but I'm just going to be a bad developer and push my code and cross my fingers and hope that everything goes well. Okay. So just like before, this push should kick off a deploy. So let's take a look. Yep, we've got a new deploy that already completed. And let's go take a look at our build history. And yep, we've got a new build kicked off, which is great. All right, so while that build is running, I want to show you a tool I wrote that you might find handy. So Atlas allows you to add IP addresses to an access list so that only those IP addresses can access your database. Now, this is a fantastic security feature to keep random people from accessing your database. The problem I ran into is that I need my automated tests to be able to access my database. And my automated tests run on Travis CI. So I need to add all of Travis CI's IP addresses to the access list. Now, as you can see here, Travis CI has a lot of possible IP addresses. So what I did is I actually wrote a script that pulls all of Travis CI's IP addresses and then adds them to the access list for a particular Atlas project. I'm not going to get into the details of how to run it right now, but I just want you to know that it exists so you don't have to sit and type 50 IP addresses manually when you want to get your test running on a Travis CI build. All right, let's take a look at that build and see how it's going. All right, so my build passed. I've made a change to my code base and my tests are passing. I could do some manual testing if I want in order to view the changes for myself. When I feel confident in my changes, I'll create a pull request to merge my changes into the staging branch. So let's take a look. What I'm going to do is create a pull request. And I'm going to say, compare my dev branch to the staging branch. Here I'll add some sort of helpful message like, make the status message more fabulous. I could assign it to myself, and if I had a teammate, I could just ask them to review it. I can scroll down and see exactly what change I made. So here we can see I changed the status message in index.html, and I changed a couple of the test cases as well. So what I'll do is I'll click Create Pull Request. All right, so here's where a teammate would come in, look at it, say, yes, this is good, or no, we need to fix some things. And then when they finally agree that it's great, they're going to click Merge Pull Request. And what this is going to do is merge my code into the staging branch. So once again, my code will be deployed automatically to my Realm app. This time, it's going to be deployed to my staging Realm app instead of my dev Realm app. Now my staging build should be automatically kicked off for me. So let's take a look. And here we can see, yes, we've got a staging build in progress. All right, while that's running, I want to show you the magic behind these builds. Every Travis CI build is required to have a .travis.yaml file. So let's walk through what's happening in mine. Here we go. So as you can see, we're using Node for our builds. Then we're installing the Chrome add-on. Next up, we're starting up the Selenium server so that we'll be able to run our Selenium tests. And we're also going to install the Chrome driver, which our Selenium tests will need. So once we have everything installed, we're ready to actually run our tests. So what we do is we say, if the Travis branch, if the branch we're on is the master branch, that means we're in production. And remember, we don't want to run our integration tests or our UI tests there based on the way I've architected my particular tests. I only want to run the unit tests. So that's why here I'm specifying to only run the tests that are inside that unit test directory. Else, if we're not in the master branch, if we're running any other build, we want to run all of our tests. So here we've got a command that doesn't specify the test directory, it just says run everything. Now finally, if the build has passed, meaning all of our tests have passed, and we're in the staging branch, we want to push our code changes to production. So this line right here is what's actually pushing our changes to the master branch. That's what's going to trigger the production build and deploy. Let's take a look at the build to see if all of that has finished. So let me jump back over. We can see this build should be finishing up pretty shortly. So here we can see that we are installing Node. We're starting up the Selenium server. We are installing the Chrome driver. And then we'll see a bunch of commands related to starting up and running our automated tests. So here we can see, excellent, all of our tests passed, which is great. Now down here at the bottom, let's take a look at what's happening here. This is what is actually going to push our code to production. So we're saying if the branch is staging, then clone our repo and actually push to master. And it looks like all of that happened successfully. So let's go up and take a look at our build history. And we can see that we've got a build to master automatically kicked off because we pushed to the master branch. All right. So assuming all goes as expected, this build will finish successfully shortly. All right, so now you've seen how code can move from my laptop to dev to staging to prod. I utilized Realm's automated GitHub deployments as well as Travis CI to create my CI/CD pipeline. All right, let's wrap up this presentation. So I want to share 3 things that I learned as I worked through the process of developing these automated tests and pipeline for my serverless app. So first up, mocks can make your brain explode a little as you try to figure out how to create them correctly. However, once you figure out how to create them, they are super handy. If you want to be able to unit test serverless functions, you're probably going to have to use mocks. Serverless functions rely on other services and integrations by design, so mocks are essential to unit testing. I'm really glad I've invested in a unit test suite so I can get instant feedback on if I'm making a breaking change to my code. Second up, this is the one that surprised me. The test pyramid reshapes for serverless apps. Your test suite may no longer look like a pyramid where you have the most unit tests, fewer integration tests, and way fewer UI tests. Serverless apps have a lot of integrations because of the way they are architected, so be prepared to write a lot of integration tests. You may have as many or even more integration tests as you have unit tests. And finally, serverless apps may require creative CI/CD pipelines. In my case, the only way to execute the serverless functions was in the cloud, so my pipeline is a bit strange. I deploy my code on the next stage before I know if it has passed all of the tests. This approach is working for me, but it does not look like a typical CI/CD pipeline. So 2 big things I want you to remember when you leave here today. First up, CI/CD makes developing serverless apps faster and easier. If you want to be able to move quickly, you need a complete suite of automated tests and the ability to easily deploy frequently. Second, you can use my digital binder to jumpstart the creation of your CI/CD infrastructure. So here's the link to the GitHub repo with where all of my code lives. The README has detailed explanations of the app architecture as well as the CI/CD infrastructure. If you'd like to learn more, I've written a blog series that details my approach for writing unit, integration, and UI tests for this app. You can find it on the MongoDB Developer Hub. I'm planning to add information about my CI/CD pipeline to the series in the future. I'm happy to answer questions now. If you have questions later, you're thinking about it overnight and you've got more questions, feel free to ask them on the MongoDB developer community. You can tag me in your question if you'd like. My team and I are there every day answering questions. If you want to get notifications about when I publish new blog posts or grab a copy of today's slides or just watch a few silly TikToks, you can follow me on Twitter. I am Lauren_Schaefer. One more announcement for you. Racial justice is an issue that is important to me personally as well as to MongoDB. MongoDB is currently matching funds that are donated to organizations that were selected by our underrepresented people of color affinity group. If you'd like to have your donation matched, visit mongodbforjustice.mongodb.events. All right, so one final question I'll leave you with today. Are you ready to create your own CI/CD pipeline for serverless apps? You've got your binder and you're ready. Thank you for watching.